School SB here. We're going to look at classifying real numbers, but before we do, let's review real quick what our real number system includes. They include natural or counting numbers 1, 2, 3, 4, 5, 6. And when you take 0 and include it with the natural numbers, you get a set of whole numbers. Building on from there, you take negative numbers and include it with the whole numbers. So therefore, you've got a set of integers. When you begin building fractions or ratios based on integers and the denominator does not have a 0, you have a set of numbers that are called real numbers, rational numbers. Again, those rational numbers are integers that create fractions. And from there, our rational numbers, there is a disconnection, a set of numbers that where the decimals, they are non-terminating decimals or non-repeating decimals. We call that an irrational number. And when you take rational numbers and include or add irrational numbers to them, you get a whole set called real numbers. So let's move the screen over some, and I'll leave this inside of our view. Let's take a look at a couple of different problems here, and let's classify. Let's look at the square root of, let me change into a pencil here. Let's look at the square root of 3. And before we even answer what type or classify what this is, let's take a look at the square root of 1, which you already know equals 1, and the square root of 4, which you know equals 2. So the square root of 3 is in between these two numbers here. So you know that the number, this answer is going to be between 1 and 2. Well, it's got to have a decimal in there. So I don't know off the top of my head what the value of the square root of 3 is. So I'm going to bring a calculator in real quick and say, okay, well, the square root of 3 equals 1.7320508, etc., etc. And I can look at the chart now, the table, and see that, hey, these decimals are not repeating, they're not the same. So therefore, this has got to be an irrational number. And take that off screen. Let's call this irrational. Let's take a look at another problem here. Let's look at the negative 5. Let's look at negative 58.85 and ask yourself, okay, well, let's look at the table here, the chart. I can see that, well, this is not a whole number because it has a decimal, and it's not an integer because it has a decimal. So therefore, it's at least a rational number because fractions can create decimals. And since it's a rational number, it can also be a real number because a real number is included. It's not an irrational number because the decimal actually terminates. So 58.85 would be considered a rational number, considered rational, or real. And let's take a look at one more here. The square root of 9 over 3. Well, the square root of 9, that actually equals 3 over 3, and 3 over 3 actually equals 1. So I know that I'm dealing with at least a natural number, and I could deal with a whole number. One's a whole number, one's an integer, 1 over 1, or 3 over 3. And so therefore it's written as a fraction, which is a rational number, and it includes a real number. So I could say, hey, this is whole, it is an integer, it's a rational number, it's also real. However, it is not an irrational number because it does not have a non-terminating or non-repeating decimal.